So today we discuss, we solve a numerical, okay, on the state model. Okay. So first of all, you need to write down this numerical. Okay. Okay. So here you can see what you need to do. We need to find out the or we need to construct the state model for the system. And what is system? A feedback system having a closed loop transfer function, that is T of S is equals to S square plus 3S plus 3 upon S cube plus 2S square plus 3S plus 1. Okay, so this question is given. Now, what we need to do? We need to construct the state model of a system. Okay, our aim is to construct the state model of a system. So, how we construct? For construction, we can split this transfer function, right? So, here you can see this is okay. So, here, so given transfer function, we can write down this transfer function. What is transfer function? It is a y of s by R of S or C of S by R of S, right? So output by input, right? So we can construct or we can split this transfer function in such a way that that is x1 s upon r1 into y1 of s upon x1. Okay, right? So we have this kind of system with us. Now we know that we have this transfer function, right? We have this transfer function. What we need to do, we need to split in this form. So when we split, we get this kind of equation, right? Here this is x1 of s upon r of s is equals to 1 upon s cube plus 2s square plus 3s plus 1. This is one equation. Okay, this is one ratio, right? Another one is that, what is next? Next is y of s, this one. Y of s upon x1 of s is equals to s cube, this numerator s square, sorry, numerator s square plus 3s plus 1, 5, 1. So when you multiply this ratio or when you multiply again, finally you get this transfer function. Are you getting my point? Okay. So when you combine these two ratios, finally you get your transfer function, right? This is okay. So in this way, we just split this transfer function. Okay. Now, Now we consider equation 1. Okay, here we consider equation 1. Right. From this equation, what we get? What we do? We just cross multiply this equation. So this term multiply with this one. So, okay, you can write down this in this way also. Write down in this way also. Here we have this one. S cube plus 2s square plus 3s plus 1, this bracket close, into this x, this x1 of s is equals to r of s, right? So I just multiply this equation, I just multiply this term with this. So finally I get this one, s cube plus s cube x1 of s plus 2s square x1 of s plus 3s 3s x1 of s plus x1 of s is equals to r of s. Are you getting? Okay, you can note down this one. Now, what you need to do? You need to convert in this form. Oh, so for that purpose, what we are doing? We just taking the Laplace inverse. So this is x triple dot 1 t plus 2x double dot of x1 of t. This is first differentiation plus x1 of t is equals to r of t, right? So what we are doing here, we just converting this transfer function into the converter. We just taking the inverse of this equation, right? So now next is what we need to we require the variables, right? So for that we can use consider this x dot of t is the, this is equals to your x2 of t. Sorry, small. Right. Similarly, we take these and remaining differentiation values or differentiate value and put this variables this form. Yes. Thus, therefore, x dot of 2 is equals to x3, and when we consider this for when we are considering this x1, so this is equals to x. Okay. Now, for similar for the x dot of 3. So here I am considering this equation. So x dot of 3 is equals to, it is a equals to x is okay. So in this way we have this all the values. Okay. Now we convert and we have, when we have all the values of this variable, so we can rewrite this equation number 3, right? Okay. So here hence the equation 3 becomes equation 3 becomes which we replace here x dot of 3 plus 2, this is x double dot of 1, right? So here you can see it is equals to x3 of 3, x3 of t, okay? So here x3 of t plus, this is x dot of 1, so x dot of 1 is equals to x2, okay? So here plus, this is 3 x dot of 2 plus, this is as it is x dot of 1 is equals to r of t. Okay. Now you need to rearrange this equation. We require the system parameters on one side of system. Equations system variable. So here we can rewrite this equation in the form of x dot of 3 is equals to, and arranged in x1, x2, x3 form. Okay. So this is minus, this complete term is become minus. So here minus minus x1 of 3, sorry, x1 of t minus t x2 of t and minus x3 of t. Are you getting? Now, similarly, you have the values, right? Similarly, you have the value that is x dot of 2, that is x dot of 1, right? Now, what we need to do? We need to write this complete equation. This here we have this 3 set of state equations, and we need to convert, or we need to put this value in the matrix form, right? For the matrix, here you can see this is x dot of 3, here we have this x dot of 2 of x of t, right? We have the 3 variables. So here we have this 3 by 3 matrix here. So here here we have this one first. So it's equals to I need to arrange first so that we can get on this equation easily. Right. So here you can see this is your equation, right? This is right? Okay. I put all the equations here so that you can understand. This is your first equation, right? This is your second equation, and this is your third equation. We do not require this value here, so I can. We say where does we have obtained the set of state equation writing them in the matrix form. Okay, right. So you have this three equation, and we need to arrange this equation, write this equation in the matrix form. So here, what we need to do, we need to write. Here we have this values, right? So here we first of all, this is x dot. This is x dot of 2. This is x3. Okay. Now here, here what is the value here? We need to put here. We have this x1 of t. Here, sorry, here we have this x2 of t, and here we have this x3 of t. Okay. Now, first of all, we see this equation here. X dot of 1 is equals to x2 of t, right? So remaining values are the zeros. So remaining value are 0, 1, and 0. Right? Now, when you see second, so here we have this 0 and 1. Agree? And when you consider x dot of 3, it is equals to, this equation is minus 1, this is minus 3, and this is minus 2. You're getting my point? Now, here we have this r of t. So in this two equation, in initial this two equation, we don't have this value. Right? So here what we get? Here we get this equation. This is 0, 0, and right? Okay. If you see again this equation, x dot of 1 of t is equals to 0, x1 of t plus 1 here plus 1, x2 of t plus 0, x3 of 3 plus 0, r of t, right? Right? So in this way you have this equation. Similarly, you can see here also x dot of 2 is equals to, here you have only x3, so remaining values are the 0. So 0 x1 of t plus 0 x2 of t plus 1 x3 of t plus 0 r of t. Right? When you consider this third equation, see here you have this x dot of 3 is equals to minus 1 x1 of t minus 3 x2 of 3 minus 2 x3 of t plus 1 r of t. Okay, so in this way you get this equation, right? So give this numbers. Equation number 4. Now, this is one portion, right? Similarly, this is for the input. Now we need to output or the equation, second equation we need to solve it here. Okay, so for the second equation, I can use the similar values from the equation 2. We can write, I just use this equation again and copy. So that is easy to me. Okay. So your equation 2 is this one. X square s square plus 3s plus 3. So here you get this s square plus 3s plus 3 x1 of s is equals to y of s, right? Now you need to multiply this equation. This is x square x1 of s 3s x1 of s plus 3 x1 of s is equals to y of t, right? Now again you need to take the inverse of this equation, right? When you take the inverse of this equation, you get, we don't have the cube, so here we get, this is when you take this equation, so here you get x double dot of t plus 3 x dot of 1 plus you get the 3 x1 of t, and here you get the y of t, right? You can give this equation numbers. Now you have all these values here, you already calculate or already obtain this value, so you need to rearrange this equation. Okay, so okay. Therefore now this equation changes here, you can see. Therefore this x double dot of 1 is represented by x3, right? So here you can write here put this very directly here. This is right. So this is now x dot of 1. So here this is equals to x2 of t. Dedicate, sorry, x2, and this term is as it is. Now from this what we get? We get the output equation. Therefore output equation in matrix form, okay, matrix form can be Then so here you have this matrix as it is. Y of t is equals to y of t is equals to. Now here you can see this is okay. If you rearrange this equation, this form equation so that you can understand easily. Wait, now you can see. This is 3x1 of t plus 3x2 of t plus x3 of t is equals to y of t, right? So here I have this variable here, and this is 1. So this is 3, 3, and 1. So here 3x1 of t plus 3x2 of t plus 1x3 of t. Okay. So in this way, you get the state model of this as a function, right? So here I am giving this equation number 6. So this equation number 4 and equation number 6, right? You can write down here also. Therefore, equation 4 and 6, 6 represent state model for the given system. Okay. I think in this way we just obtain the state model of this equation.